Wild Style Basketball AI. So the way we have it set up is that all of the AI decisions at the top level as to what am I going to do next. Am I going to guard? Am I going to shoot? Am I going to pass? All of those decisions are made using the values from this spreadsheet. So the way it works is you can change the spreadsheet around by changing any of these cells. So noting that the columns and the rows combine as follows. So the columns represent the variables and the states that are currently in the game, and they each have a value or not to select a suggestion of the next decision you're going to make. So for instance, if you are an offense person and you might make a decision to receive, you look at the cells for all of the various states and variables that might go into that. So for instance, if the opposing team is on offense, you can't be an offenseman, so that negates that decision. If the game is paused, you can't choose to receive. So an X means it completely negates your even thinking of that suggestion for your next move. So shot clock time, the 0 means that there's no effect from shot clock time onto the decision to receive. So receive would be no better or worse than any other choice that you might make based on shot clock time alone. So here's another one. If the dribbler is in a state of passing, you can see that up here, dribbler's state is pass, that contributes a little more heavily to the idea that you as an offense person might be wanting to receive. So this is the cell. So dribbler doing a pass means you're more likely to choose to receive the next time you make a decision, which should be pretty quick. So that's what the numbers mean, most of them. The other options here are shorthand for formulas. So they have a letter in them, either a D or an I. The D stands for direct, meaning that the more there is of the value in this column, the more likely this decision is to be made. And I is inverse, meaning the opposite. The higher the value in the column, the less likely the decision is to be made. So for instance, let's take the dribbler speed with respect to receive. So the dribbler going very fast means that the dribbler might be going for a shot or rushing the basket. So you're less likely to receive the faster the dribbler is going. So the 3I1 stands for, it's like an equation. If the dribbler speed is x, you choose 3 times that x raised to the first power. So the 3 is the coefficient in front of the formula, and the 1 is the exponent of the formula for an inverse function, a simple inverse function. So if dribbler speed was 5, you would multiply that by 3 and invert it, so flip it. So it would be 15, and then you flip it, so it's like 1 over 15, which means that you have a very little chance of choosing that as compared to, say, the 5 we looked at for the dribbler being in a state of passing. So anyway, that's direct and inverse formulas, and the shorthand needs to be followed kind of to the letter, because when these are loaded into the code needs to understand exactly what the formula is. So let's see, the instructions over on this side give kind of examples the same way that I was just explaining them. So let's go down a little bit here to number 2, which is the current situation. So remember, all of these columns, they have to have a value, and so the actual values of these columns are here. And now this is, when you're doing playtesting, this is what you would change first to see what pops out for decisions. So you might change dribbler speed to a 10 and see what happens to the values for like the offense player. You might have the the game time left be 200 and see if that changes anything too. So most of these are true-false, meaning that you're in a particular state or not. But these other ones are numeric variables, and they relate back to these formulas. And you can see up here that you have a min-max of the variables that could be in the game. So there could be 24 seconds left on the shot clock, for instance. The dribbler could possibly be going at a speed of 10, which is highest. Right now it's 5. So you pick the values, and when you change anything in this sheet, the results automatically update. And by results, I mean these. This is what decision you're going to make. So this is the team strategy winner for whoever it is. So this is the person who's doing the decision making is a baller on defense, because this is the only true state. Baller on offense, baller on defense. So if you have the ball, that's also like a state for you. Let's see. So let's change this one from true to false. Stuff changes, and this one from false to true. Whoops. And that changes again. So notice how things say continuity and chaos. I'll get back to that. But team strategy is a slightly higher level. This is what the team might be doing. And the team might be guarding the basket, guarding zones, guarding each other. And so the team strategy will have a decision, and the player themselves will have another decision. This is all part of the AI suggestion model. You want to have a team strategy and you want to have a player tactic. So you might want to follow the team strategy if you're a player, but you might not. So anyway, the other parts of the variables that I didn't mention that get played into this are stats. So you are a baller and you have a pretty good idea of what your own stats are. And you might make a decision to shoot if you're a good shot, or run if you're a good runner based on that. So these letters here are kind of like they're formal stats equations which relate back to this page here. And these are formulas that my illustrious colleague St. John has put into the game. So if you see this shoot base, distance of basket, shoot base, block base. So these refer back to yourself, your own stats, and also to the stats of the person who might be blocking you, for instance, if you're deciding to make a shot. So the way that translates into the suggestion model is if you have your own stats and you have a kind of reasonable idea of the opposing team's stats, or even people on your own team's stats, that feeds into this formula. So the formulas themselves are listed up here. I mean, you probably don't want to change these. So these formulas relate to your own stats and the opposing team stats or whatever. So here are the stats themselves, which you can change. And these are directly taken from the player tab, but you can change these as much as you want just on this sheet to say, like, okay, here's the dribblers. Let me make the text there a little more visible. Format cell, alignment, -90 degrees. So you can kind of see the different players here and their stats. Now you as the player might not, if you don't really know, you have a confidence level in knowing your opponent's stats, and right now it's 7. And you have a confidence level in knowing your teammates' stats, which is 0.9, and those get fed into the formulas as well. Now might be a good time to talk about the chaos and continuity factors. So right now, the way this works is the decisions get, all the possible decisions, meaning the ones that don't have an X in the cell, depending on the states. If there's no X and that decision is a possibility, then you put all the decisions into kind of like a random hopper, and they have various strengths for the suggestions. So for instance, the suggestion strength for zone guard is actually less than the basket guard and baller guard, but it got picked anyway. So it's random, and so it just has a lower probability of being picked. However, this continuity factor means you keep doing what you're doing despite what you might have come up with as another decision. So if you are making decisions, say every few seconds in the game, that might be a little counterproductive if somebody else is kind of thinking of a play that you should be part of. So the continuity is part of it, and it could be a different factor for each player. I should mention that this spreadsheet and all the decision-making factors that go into it can be different for every single player. They can be the same, but they can also be different for every player. Chaos is just for unpredictability purposes. Even if the randomization of certain decisions is fairly strong so that you get a lot of replay value and unpredictability yet some reliability, if there's a higher level of chaos, that gets changed sometimes. So what chaos does is there's a small chance that you will pick a decision and it will get rejected. And then you will have the next most popular one or another random one suggested. So for instance, player tactic winner. This 43, the baller would be more likely to rebound. But instead, they decided to stand idle because chaos. So again, all of these values up here are tweakable. All of the values up here are tweakable. So if you think that 3 is too low a value for if the opposing team is receiving and you think that would make you more likely to guard, you might change this from a 3 to a 7 and see what happens there. So far, okay, this changed this so that the player tactic winner, the decision that got made, even though it was chaos, was to rebound. So note, when you change any cell up here, which you're probably likely to do based on playtesting, or you just change any cell here, which is going to change a lot based on what you think the current state of the game is, then all of these decision values will change and all of the actual decisions that are made will change. So these are some randomization numbers that get used for the various values choices. You want to leave those alone for now. Anyway, let's see what else is on this sheet. So this is just kind of a definition of the steal base. You look at the stats, agility, and speed, and that helps out with the steal equation, which again is one of these up here. You can relate the letters here to the letters on the stats equations here. Oh, also this stats weight is how much do stats and considerations of stats contribute to the decision. I believe 1 is low. So anyway, that's kind of how the sheet works. And now there are 2 other parts to the AI system. They are both in Unity code. The first one is the importing of these values goes into a file, or a script rather, called WSBB-AI.cs. WSBB-AI.cs, the script, completely mimics the operation of this spreadsheet, as in when you change values here, the same equations are used to get the results. So what happens is you import this set of values into the game on a build. Then during the game, these values all change, the shot clock runs down or the dribbler starts going faster. At that point, all of the values are referenced in the game and the decision is made to do a particular move or particular course of action next. So that's the top level decision. The other part is what I call mini AIs. Now the mini AIs are in a file called ballerai.cs. Now the mini AIs, each mini AI is the actions taken or the thoughts taken by one state once that state is decided upon to be the next move. So all of these rows here, steal, block, guard, intercept, they are each a state in a state machine, and each of these states has a mini AI deciding the fine details of what to do in that decision. So for instance, pass. You decide to pass. You still don't know who you're passing to. You still don't know where they are. So you go to the state machine, and in the state machine is the state pass. And in pass is a function that tells you where to pass to if you need to like kind of move a little to get more opening, etc. And that kind of like fine tunes the pass. The mini AI in the pass state fine tunes it so that you're able to pass more intelligently and reliably. So again, this is the top level. This sheet is the top level. Then once a state is entered, a mini AI takes over and does the fine tuning. So that is the story of the AI in WSBB.
This has been a presentation of the National Mark Radio program. Please join us next week when we do a hats off to Kimbabwe Tsumawe, the inventor of the skirt.